Good evening everybody, welcome to another tutorial, and today we are going to be looking at another inverter. This is it's got power inverter, so that's probably what I'll put the title as. And this is a 1000 watt modified sine wave power inverter. I have shown one exactly the same like this in the past, but this is actually a different one. The one that I used to show in the past on my past tutorials, when I first went off grid and I showed it, that one has actually been sold. Yeah, so I thought I would review this one since I bought this one quite a while back, last year. And yeah, because I've also upgraded, so this one has been disconnected from the solar setup. So I thought I'd do a review on it before either I put it away as a backup inverter or I end up selling it. I'm not too sure which one I'll do at the moment, but anyway, without further ado, let's get into it. So 1000 watts, 1000 W max. I don't think these have a surge output. I think these just have 1000 max, and once it just exceeds it, it'll just cut itself off. So it's got one USB port, as it says. It's a power inverter, 12 volts DC to 240 volt, 220 volt IC. At the back here we've got positive and negative poles and a fan. Nothing on the sides. And on the front we've got one USB port and one 220 volt AC inlet, or output actually. Not input, output, so you know the power comes out as a modded. So a pure sine, so this is a modded sine wave. So a difference between a modded sine wave and a pure sine wave, which the last one I reviewed was a pure sine wave, is the modified sine waves produce what you call a square wave. And when I plug this charger in, you'll actually hear a audible version of it, because it actually creates a buzz, a loud buzz in certain appliances, like a fan, or in this case when we turn this charger on, that's inside the slow cooker. But in other devices you don't hear an audible noise at all, but that's just because of the sine wave that's produced. So a pure sine wave, if it was a normal household, a normal plug, that's what you call a pure sine wave. It's a circular wave, so it just looks like that. We see a square wave is what it's, I think it's square waves that go like that in squares, and that's the sine wave. In the middle of each up and down is 0, and the top and the bottom is the positive and negative of the sine wave, and then it switches in between as the sine wave's doing it, and depending on how much it does it a second, depends on and that's what you call frequency. So if it does it 50 times a second, that's 50 hertz. If it does it 60 times a second, that's 60 hertz. Which 50 hertz is what we use, and 60 hertz is what parts of the United States of America use. So, but anyway, I'm rambling a little bit. Without further ado, let's have a look at what we expect. So what we're going to do is we're going to hook. We've got a battery here. We're going to hook this battery up. When you're hooking anything up to a battery, it always pays to hook the positive terminal up, the negative terminal up first. So this is our negative terminal. So we'll plug that in. I'm just going to tap the positive part of the battery because it does spark. It will spark. This doesn't have an anti-spark thing, so I'll just quickly tap it and then I'll disconnect it just so I don't get a shock. So what we're going to do is tap the positive pole. You'll hear it too. And yep, actually it didn't do a shock that time, which is quite surprising. So we're hooked 2 up, and now we have a light. So with this, see, that turns the inverter off and on and off. With this inverter you can have the inverter off like what it is now in this configuration, and you can still use the USB port. So if we grab the other end of this USB cable, it's tangled for some reason, and what we're going to do is we'll plug it into this Bluetooth speaker, and it should start charging it. There we go. So we are charging at 5 volt DC through the inverter while it's off. So that's one thing you can do with this inverter. You don't have to have it on to charge with the USB. I used to use this to charge my phone a lot with the inverter off. This used to be hooked up to my entertainment system, because since it was an entertainment system, you know, you didn't really think much of it. Because yeah, it was an entertainment system and it wasn't sensitive equipment, or equipment that was consequential. If they did break, I'd be in trouble. So yeah, that's the 5 volt DC side of it. So what we're going to do is I'll show you what I mean, also by square wave. So what will happen is, this is a battery charger, a 9-stage battery charger. Usually when I have this plugged into the wall, it has no buzzing to it, but what you're going to notice, you're going to hear a loud buzzing coming from it when I turn the inverter on, because as I said, it creates what you call a square wave, not a pure sine wave, and you'll hear the audible sound of the square wave. So I'm just plugging the charger in. I'm not going to turn it on, I am just going to plug it in. I'm not going to charge anything off it, because it's not recommended to charge anything off a modified sine wave inverter. But to hear what I mean, you'll hear the audible noise. So I'll turn it on. See, it's a bit, I don't know if you can hear that buzzing noise. That's what you call a modified sine wave inverter, or modified sine wave. It's audible. See, if I turn it off, you can't hear it anymore. If I was to plug this into a normal plug or to a pure sine wave inverter, you wouldn't hear no buzzing at all, even while the charger's not even charging anything and just on standby mode. So that was just imitating a audible version of a sine wave. But anyhow, besides that, we have a non-sensitive appliance right in front of us, and it is a slow cooker. So with appliances like this, they don't mind the square wave, because it doesn't got a, first of all, it doesn't got a computer in it, and second of all, yeah, as I said, it's nothing sensitive. So you know, it's just got a heating element on it. So what we're going to do is we're going to plug this into the battery, or into the inverter, which is plugged into the battery. And I just got to hold the inverter down, because you got to push it in quite things. So now we can turn the inverter on, but we're not drawing any current yet. It's only because the slow cooker's off, but the slow cooker works fine. See, now the slow cooker's on. The inverter hasn't tripped yet, so yeah, we are heating up a slow cooker off a battery. Look at that, guys. You don't hear the audible noise in this appliance. So so some appliances you don't hear the square wave noise. It's usually appliances like fans and chargers like this. It creates a audible noise when you're using this modified sine wave inverter. But as I said, for equipment like this, if you're just going to run like a slow cooker or slow cookers off it, it'll work fine, because these equipment don't mind dirty electricity. It'll even work with a generator that's non-inverted. It'll even work with inverted. But if you wanted to buy a cheap inverter just to power non-sensitive equipment, this is perfectly fine. So yeah, I just thought I would demonstrate a 1000 watts modified sine wave inverter, since I have reviewed a pure sine wave, and I will also be reviewing another pure sine wave inverter later on. So yeah, hopefully you've learnt something new. I just thought I would show this in action, operating two devices on it, a slow cooker the humming of the charger, you heard it was on, and also the third device charging a USB Bluetooth speaker off a 5-volt DC source that is provided, aka USB. So without further ado, hopefully everyone has a good day. Yeah, I just thought I'd bring this one to you before it either gets sold or put away. I haven't quite decided yet. I'm leaning more against the latter, selling it, so because as I said, I've replaced it with a new one. So hopefully everyone has a good day, and until next time, cha-cha.